What's up everyone? Today I'm going a full mini split installation. I'm going to walk you through every single step, from mounting the first wall bracket all the way to turning the system for the first time. The system going in today is 9000 BTU Fujitsu single zone unit. Fujitsu makes great equipment, reliable, efficient and built to last. This one is going into the bedroom and the outdoor unit will sit on a sidewalk next to the house. I won't just show you what I'm doing, I will also explain why, because knowing the reason behind each step is what makes difference between a good install and a great one. Let's get into it. First thing we do inside is mount the backing plate for the air handler on the wall. The air handler is also called the evaporator unit. It's the indoor part of the system that blows cold or warm air into the room. The plate is what holds it up, and getting this step right really matters. The plate has also to be perfectly level, not close enough, perfectly level. If it tilts even a little, water from the drain inside won't flow the right way. That means water dripping into a wall or into the floor. I use a stud finder to locate the wood framing inside the wall. Then I drive the screws straight into the studs. Drywall anchors alone aren't strong enough for something that's going to hang for there like 20 years. Once the screws are in, I check the level again. Then I give a plate a firm tug to make sure it doesn't move. If it holds, we are good to go. Before you start any part of this install, read the manual for your specific unit. Fujitsu includes torque values, wire specs, clearance requirements, and startup procedures, and they are not all the same across the models. The nameplate of the unit gives you basics. The manual has the full wiring diagram and breaker sizing. Always cross-check both before you pull a single wire. Now, we drill the hole through the exterior wall, about 2.5 inches wide. This is the hole the refrigerant lines, drain tube, and control wires will pass through. The first time you do this, it feels a little scary, but it's totally straightforward if you follow a couple of simple rules. Number 1, angle the hole slightly downward towards the outside. That way, the drain pipe will have a proper slope by default. Number 2, know what's inside the wall before you drill. I already checked the wires and know where the threading is. And I'm using 299/16 inches SDS Plus crown for this. And this one of those moments where a good tool makes a real difference. Sharp quality bit cuts clean and doesn't tear up the drywall or siding. A cheap bit wobbles, overheats, and makes a mess. The drilling through the wall always makes a mess. Insulation, dust, wood chips, siding debris, drywall dust, it goes everywhere. I drilled with the vacuum running to catch all the fine dust, but the bigger chunks still fall. So before run anything through that hole, I clean everything up on both sides. And I vacuum the floor. I like to be nice and clean. The lineset is the backbone of the whole system. It is insulated copper tubing that connects the indoor and outdoor units and carries refrigerant back and forth between them. For this Fujitsu, we are running 1/4 inch and 3/8 inch pre-insulated line set, the right size for this unit capacity and the length of the run. Fitting it through the wall is doable solo with a little patience. One thing you absolutely cannot do is kink the copper pipe. Copper is soft and flexible, which makes it easy to route, but if you bend it too much, you will get a kink. Kink blocks refrigerant flow, hurts performance, and over time can damage the compressor. I'll keep all my bends low and wide to stay out of trouble. Once it through the wall, I route the line set down the exterior towards the outdoor unit. Keeping everything neat and straight, a tidy run makes the finished cover look much better. Now I'm moving to the outdoor unit, called the condenser. It needs a solid stable place to sit. For this install, I'm using 3-inch anchor bolts to strap it right to the concrete. Where you put it matters. Fujitsu specifies how much open space the unit needs around it to breathe properly. At least 12 inches on the service side panel, with the clear space above, and 6 inches on the back side. Once it's in position and level, I strap it down tight. This step isn't optional. Wind and vibration can slowly shift an unsecured unit over time, and if it moves, the refrigerant line connections can work loose, and a couple of times I saw the units like this stolen. So, a couple of bolts and this unit isn't going anywhere. Right next to the outdoor unit and within inside of it goes the service disconnect. Most local codes require this, and for good reason. It lets technician cut the power to the outdoor unit there on the spot, without walking back to the breaker panel. And it's a safety feature, and it's very handy during the future service calls. I'm installing non-fused 30 amp disconnect rated correctly for this unit. The box gets secured securely to the wall. The power line will run through it and on its way to the condenser's electrical compartment. Now, we pull the electrical wiring. This Fujitsu unit runs on dedicated 120 volts 15 amp circuit. Dedicated means nothing else shares this breaker. The wire gauge has to match what the unit's nameplate calls for. I'm running 14 gauge wire from the panel through the crawl space into the disconnect box, and then over the condenser through the liquid conduit. I always run conduit on the exterior electrical runs, even when local codes might give you a pass on it. Conduit protects the wire from the sunlight, physical damage, and pests, all real threats over 15 years of service life. I cut and fit each piece cleanly, use proper elbows, and strap it to the wall at the regular intervals. It takes more time, but it looks professional, and it will be still great shape after years from now. Every connection gets torqued to a spec with a calibrated torque screwdriver. Loose electrical connections are one of the main causes of failures, and in the worst-case situations, fires. A quality torque screwdriver makes this step quick and reliable. Every hole we made through the exterior wall needs to be sealed up tight. This is where expanding spray foam comes in, and the type of the foam you choose actually matters. I use dedicated penetration filling, minimal expanding foam to seal it. This one step solves three problems at once. It blocks air leaks, stops the moisture from getting in, and seals out bugs and rodents. Once it's done, you can't see it, but you will thank yourself later. If there is one step in this whole install where you need to slow down and pay close attention, this is it. Layering the copper refrigerant lines is the step that most often causes refrigerant leaks. A leak means the system loses its charge, stops working right, and needs a service call to find the leak, recover the refrigerant, and recharge the system. That's expensive and totally avoidable. A good flare starts with a clean, square cut on a copper tube. I use a quality tube cutter, not a hacksaw. Then I deburr the inside edge so there is no rough copper that could damage the flare or get into the system. Then I make a flare itself with the Redstone flare tool. A good flare tool is the one of those purchases you don't ever regret. Every flare comes out consistent, smooth, and uniform. A cheap flare tool makes uneven flares that don't seal properly in the fitting, so no amount of tightening will fix the bad flare. Once both ends of each line are flared, I put a small drop of refrigerant oil on the flare surface, thread on the flare nut, and tighten to the torque value Fujitsu specifies. It is highly recommended to use an actual torque wrench, especially if you are not dealing with it every day. Too tight can crack the flare. Too loose leaves it leaking. Before we open the valves and let any refrigerant into the line, we need to prove two things. The system has no leaks and there is no moisture inside. This is a two-stage process and both stages are mandatory. First, we pressure test with dry nitrogen. I charge the system up to 300 psi and hold it. Nitrogen is safe, cheap, and won't react with anything inside the system. If the pressure holds steady, we are tight. If it drops, there is a leak, and we find it and fix it before. refrigerant is involved. I checked every flare connection with the leak detector solution. It's a soapy water and I'm just simply waiting for the bubbles. Once the pressure test passes, I vent the nitrogen and pull the deep vacuum with the two-stage vacuum pump. And the two qualities matters here. A cheap single-stage pump cannot pull deep enough to remove all the moisture from the lines. Moisture inside the refrigerant system reacts with the refrigerants and form the acids that slowly destroy the compressor from the inside. That's a slow motion failure nobody wants to deal with. I target 500 microns or below on the micron gauge, then isolate the pump and watch the reading. If the vacuum holds steady, the system is clean, dry and ready for the refrigerant. The control wiring is what lets the indoor air handler and the outdoor condenser talk to each other. On Fujitsu system, it's a 4-conductor cable running between two units, with each wire landing on a labeled terminal on both ends. These are signal wires and power supply wires. They still need careful attention. Each wire has to land on the right terminal. Fujitsu labels their terminals clearly and consistently, but I still double check both ends before closing anything up. A wire on the wrong terminal might not break anything right away, but you will get a fault code when you try to start a system and it won't run. Taking 2 minutes to verify everything now saves a real headache later. Now we make the install look finished. Instead of standard PVC plastic channel covers you see on the most mini split installs, I'm making a custom sheet metal cover for this one. Honestly, because I ran out of PVC cover and didn't feel like driving to the store for more. But I'll tell you, the result actually looks better. I measure a full run of the lineset on the wall, then lay out the sheet metal flat. I mark the bed lines, I cut the pieces to the widths, and form the bands on a handbrake. Once the channel pieces are formed, I make end caps and any corner pieces needed to follow the wall. Anything get depured and cleaned up before it goes on the wall. I fasten it with the metal screws, keeping the spacing for the clean look. The end result looks intentional and solid, not like afterthought. It also protects the refrigerant line insulation from the sunlight, which would break it down over the time if left exposed. Custom sheet metal takes longer than snapping together plastic kit, but sometimes it's just faster to make the things than go buy it. As the air handler runs, it pulls moisture out of the air. That's part of how it cools and conditions the space. That water has to drain somewhere. On this install, I'm connecting the condensate drain line from air handler and rounding it outside along with the line set. The one rule with the drain lines is continuous downward slope on the whole way. I'm using a vinyl tubing and supporting it at regular intervals to hold the slope all the way to the end. This is the moment everything comes together. All connections are made, the electrical is verified, and the vacuum held solid. I open the liquid and suction service valves on the condenser slowly. This releases the factory refrigerant charge into the line set. Then I power the system and let it go through the startup routine. The first thing I listen for is a smooth compressor start. No rattling, no hard knocking, no strange noises. Once it's running, I start taking measurements. I check the supply air temperature coming out of the air handler, the return air temperature going in, and calculate the difference. On a properly running system in the cooling mode, I expect to see a 15 to 20 degree split between those two numbers. I also check that the outdoor unit is running steady and clean, and that the drain line actively flowing from the air handler. Everything checks out, the system is up, running clean, and doing exactly what it's supposed to do. That's what a solid installation looks like from the first bracket to the first run. If you have any questions about any part of this, Drop them in the comments, I read them all. And if this was useful, hit subscribe because there is more of this coming. See you in the next one.